Hi, I'm David. I'm from Prague, Czech Republic, and today I will talk about Firebase mostly and all these other technologies. I would like to set some expectations that this is more advanced talk. It's not an introduction to RxJava. I'm sure you have seen so many talks, introduction to RxJava or MVP. I expect that you have at least read some article what RxJava is about, and this talk is more about how to use this in a real production app, not just a simplistic example. So something about me. I have my own company in Prague, Czech Republic. We are working on an app called Settle Up. I will talk about it later. I'm also Google Developer Expert for Android, and I'm organizer in GDG Prague. So this is our app, which you can find in the Play Store. I will tell you what this is about because I will be showing some code examples directly from our app, so you should know what the app is about. So it's about group expenses. It's for like groups of friends who travel together or live together, and they enter different expenses into the app, and the app then tells them who owes who and who should pay next. So this is the app, and a year ago I decided to quit my day job, focus on this app full time, and we decided to redesign it completely. So this is how the new redesign looks like. We are using different colors for different groups. That's not important. But when we decided to redesign it, we also said, okay, so let's change more things. Let's change also some architecture. Let's change the backend. So it's actually a completely new app from scratch. And we started using Firebase. We were in early access preview from Firebase team even before it was announced on I/O. So we had some head start and we knew where it is all going. And we have been working on this for a year, and we are almost ready to release. We are currently alpha testing this. So why Firebase? So Firebase used to be this startup, which was really successful, mostly about the real-time database. And then Google acquired this company, and they created this huge set of services. One of them is the real-time database, but Firebase is now much more than just the real-time database. But in this talk, I will focus on the real-time database. And when I'm talking about Firebase, it's usually about real-time database, but just to get the technology right. Okay, so what's so great about Firebase real-time database? So first is serverless. What does it really mean? Is that it doesn't mean there are no servers, but it means that everybody is a client. Even my server is a client to Firebase. And Firebase is this central place where everybody connects to, and Firebase is doing the synchronization. It also means that I don't need to hire backend developers because everybody is a client, so everybody is like a front-end developer. The biggest thing which Firebase solves for us is the synchronization. Before Firebase, in the current app, I had to write my own synchronization logic, and it's quite hard to get it right. Even today, in some very specific conditions, especially on mobile, when the connection can drop out any minute, it could happen that some data gets duplicated or something in some very specific conditions. And if you use Firebase, you don't have to care about this. It's really here for a long time. It's bulletproof. And another problem it solved to us, it's offline. So in Firebase, you just one line say like enable offline true, and it caches all the requests and all the data on the disk, which is really great. Before Firebase, we had this many classes which handling like SQL-like databases just for solving offline. And of course, there were some bugs and like a lot of development time. Now it's all done for us. And final thing, it's real-time. Real-time is in the name, which is kind of like nice to have for us. It's not the main reason we have it. But it's nice that like you don't need any like synchronize now button or refresh data. It just updates automatically all the time. It's quite nice when you add something on one phone, it's synchronized to other phone almost instantly. So now I want to talk about this app a little bit. I'm sure you know it. It's a Riga Dev Day app. Have you used it? Yes, so it's based on Firebase. It's actually open source. Here's a link to GitHub. And I was looking at the code because I saw some bugs, so I was interested how how it is. And there is actually a bug if you are trying to rate a speaker there, and somebody else is also rating a speaker at the same time, you lose what you have written there, which is kind of bad because it's bad user experience. And actually, in this app, what they do, actually, the author is in this room. No hard feelings. He's a great guy. He did it all on his own time, and the app is great. But here they listen to the root of the database, and when anything changes, anything anywhere, they just update the UI and delete what's already there, which is really bad. Even if you change rating of some speaker, the whole screen gets refreshed, which is not very good. So I could rename this talk to "How to Fix Riga Dev Day Android App." Yeah. So let's go back to Settle Up. This is one of the screens of our app, and during this talk I will go through the code how we create this one screen. So this screen is for permissions in a group, so you can invite your friends, and then you can see here who has the permission to the group in Settle Up. One person is the owner who created the group. Then more members can have like edit permission and more read-only permission. You can also, here is joining via link. You can turn it on and off. So this is the screen, and now I will show you the data in Firebase which are shown on that screen. So the structure we are using. So as you maybe know, in Firebase, you should really flatten your data. You should not nest too deep into this JSON, because if you nest, then you would have to download everything. If you just want to get maybe like group name, you would have to download all the nested data. So it's good practice to flatten and only download what you really need from the tree. So Firebase database looks like a JSON on the server side. It's not saved as JSON. It's like NoSQL database, but like for simplicity and like for you as a developer, you work with it like JSON. So this is how our JSON looks like. We have groups. Here is the information if the link is active. Here's the name of the group. Here we have the permissions. So group ID, then individual user IDs, and this level, it's a made-up number we made up. So the 30 for us means the owner, 20 is write permission, 10 is read-only permission. Then we have like database of users, information about the user, and this thing is mapping between users and groups. So you know in which groups is this user. And also users can customize color for each group, so that's why we have color. Different groups can have different color for the same group. When you are writing the database structure, you should also think about database rules, because you don't have any backend to do some logic like who can access what. So you write it everything in this database rules. It's another JSON, and this is example how it looks for us. You can see that you can do quite complex stuff there, because we have these 3 permissions. That's no Firebase concept. That we decided we want these 3 permissions, and you can see you can write like this, that accessing groups. You can read it if you have read only or more, and you can change it only if you are owner or more. The third is owner read only. Yeah, this is even more complex. That's like for adding new permissions. So you can new data means when new data is created and data is existing data. So you can do the conditions based on if the data is already existing or if you're adding new data. So you can add new permission, but you cannot change, you cannot make yourself owner, for example. And here, that's quite simple. The user can, like anyone sign in. This means anyone sign in can read other users, but only you can change your user. Nobody can change your email, for example. Only you can change your email. So that's the rules. And now let's talk a bit about RxJava. So why we chose RxJava? Well, why it's so great for this? So it's reactive. That's like a buzzword today. But what it really means is that in Firebase, anything can change anytime. It's real time. So when the user is on the screen, any field, anything can change. And it's quite different approach to programming, because traditionally what you do is like you call some REST API, you get the data, you show it on the screen, and in that time it's static. Until user does some actions, it's static. But with Firebase, no, it's not static, it can change anytime. So that's why it's reactive, and you have to approach it this way. It's also functional, another buzzword, but it's quite nice for like code readability. That you can lose all the for loops and ifs, and you can just call functions on data. So you just work with this stream. What it solves nicely is background threads. So any processing of the stream you can delegate to background thread, then get the result back to the main thread. It's quite nice way how to work with threads. But RxJava is quite hard to learn, I would say. That's why there is so many talks, introduction to RxJava, and it took us several refactorings to get it right. Like it's really easy to do it wrong. And I still think we have some place to improve. So like investing into RxJava is quite hard, especially for like junior developers. That's how it is. Okay, so let's see some code. When you have Firebase, this is the Firebase API. You add this value event listener, and when anything changes, you get this callback on data changed. And but it's not reactive. It doesn't give us observables. We need observables to work with it in RxJava. And this is a simple wrapper, how you can turn like non-reactive API into reactive, how to to bring it to RxJava. When something changes, we call on next, and when it's cancelled, when it's some error, we use null here, because in our app, anytime that user is on some screen, he can lose access because somebody can remove permission to him. So anytime you can get this error, that means you just lost access to this data, and we use null to work with that and handle this case. Here is in this cancellation. When somebody unsubscribes from the observable, you should remove the listener. So this is again a Firebase API where we remove the listener, so we don't listen all the time if the user leaves the app. This new observable create has supports back pressure. That's nice. So we use this strategy for back pressure. I will not go into details, but it's nice that it supports it. In the past, it didn't support back pressure, and it was actually discouraged to use observable create, but now it's okay. Yeah, I didn't say we are using RxJava 1.27. There is now RxJava 2.2.0. We didn't find enough convincing reasons to migrate our code. The old RxJava works very well, and all the concepts are the same. There are some new things in RxJava like flowables, but for the understanding, it's okay to see RxJava 1.2 point something. And yeah, and at the end we observe it on computation thread. So everything what we do with the Firebase data is done on the background. So it's really nice that it doesn't block the UI. Okay, so this is the first step. And as you can see, this code, there's a lot of like boilerplate, especially this like action1 emitter. And if you see the same version in Kotlin, it's much nicer. So especially the lambda functions are simplifying that a lot. But there is much more language features in Kotlin. Why is it really nice? And I will highlight some of them. So functions in Kotlin are fun, but otherwise it's pretty readable. Yeah, here's nothing really special. Yeah, nullables here. So by this question mark, I say that this can be null because in this case we return null, and that forces us to handle the null case in everywhere else in the code. It's kind of nice. So we cannot have a null pointer exception because we are forced by this. So rest of the presentation, the code will be in Kotlin. I will explain some of the changes from Java, but as you can see, it's pretty readable. It's quite easy to learn, and I definitely recommend switching to Kotlin for new apps. So as you see, Kotlin is concise, but the best thing about Kotlin is that it's interoperable with Java. So you can use any Java libraries, any IntelliJ plugins, whatever. Like it really works really well with existing Java ecosystem. It's also functional directly into language. So sometimes it's really nice to use some functions directly on collections, for example. And as I said, it's really easy to learn. Like RxJava is much harder than Kotlin. Like Kotlin, when you are starting, you can even convert existing Java code to Kotlin, and this way you can quickly learn the differences. And then when you start modifying this code, you learn a little bit more. It really took me just like a few days to get good understanding about Kotlin, and there is also a lot of content online for Kotlin. Okay, so let's continue with our code. So now we need to read many parts of the database, and then we will connect them to the UI. So I have this object in Kotlin. This means Singleton. So this is Singleton, which is available from everywhere in the app. It's like a global Singleton, and I can call it from anywhere. Database read.group. So I read group, for example, and this is the API we use. This apply function is like how you do builder pattern in Kotlin. It's quite nice because we have multiple parameters, not just path, not in this code, but then somewhere else maybe I can sort the query, stuff like that. And this way you can do nice builder pattern without all the boilerplate. So I create this query to the database, then I called observe method. I will show you this method later, and then I parse, because Firebase is giving me database snapshot object, and I have to convert this database snapshot to some like actual class. So all we need for that screen is these 5 calls to Firebase. So now, yeah, the observe actually observe was here. This is the observe. Sorry. So this is the observe, and now I will show you the parsing. So parsing is just a simple map function, which is taking the data snapshot from Firebase and converting it to something else. I'm handling the null case here, So it's easy for like generic type. I will just this is Firebase API. I will just call get value. It converts it. I also have this is for primitive. This is for object, and this is for a list. For objects, I also set the ID from Firebase to the object. It's quite helpful to have ID of the node in Firebase in the object. So I do it here. And same for the list here. And now this is, I think, like most complicated slide of this presentation, but also most important, which shows the true power of Firebase. How to combine multiple Firebase queries into like just the data you need for that one screen. So data what I need for that screen is this class here in the bottom. Another nice thing about Kotlin is these data classes, which if you annotate class data, it will generate all like hash map, hash code, and toString methods, and getters and setters. It will all do it for you. And so it's really nice like this. So in this class, I need one user which is owner, several users which have the edit permission, and several users which have read-only permission. So this is what we need for this displaying in the activity, and the input is database read dot permissions, which is just a list of permissions in that group. So for this transformation, I'm using this three functions from RxJava. They are, I think, most important for working with Firebase. So that's map, flat map, and combine latest. I will quickly explain. So map is a simple map of one object to another. It's no magic there. Flat map is a little bit more complex. It maps one object to an observable. That means from one object you can generate multiple objects. And combine latest, that's the main workhorse here. It's actually combining the data. So it will listen to multiple observables, and when all of them emit something, it will the inner lambda will be called, and then you can merge everything. And also, when anything changes later in each of these, then it will be called again. So you get updates. Even if one part of the observable changes, you get updates. And another great thing is that when you unsubscribe from the combine latest observable, it will unsubscribe from the individual observables. So it's very clean. So let's go through this code. And here is what this function returns. So this method returns observable with a list of permissions. Then we flat map it. If we flat map it and we call it here, it means like what's here in this method. So we get a list of permissions, and from that we will create a observable. So it will, from this list, it will emit individual items. So it will take this list and create individual permission items. So observable of permissions. We map these individual ones into this, and we need to get data about each of these users. So we have this permission object, but permission objects only have user ID. It doesn't have data like email or name of the user. So we have to query the database again here for based on the user ID, and then we combine it with the level. Level is level of the permission. That's like if the owner or read only. We are using this helper object user level, which is just binding these two information together. It's just temporary. We don't need it at the end. We need this. And then we put it back to the list. It will create this horrible thing. And Then again, we flat map it, and we call combine lane test of all of them, of all these user level objects. Sorry, and this is just normal Kotlin code. Then now we have a list of observables of these user levels, and this is normal Kotlin code. This is not RxJava. We just create this list which we need. Go through it through for each. We could have used even normal for each. This is like functional for each, and we just add it to the list. There is nothing special, and then we return this what we need. So yeah, there is a lot of code like that in the R app, which is merging multiple Firebase paths together. I think every application today should have some kind of architecture. We use MVP. Why? So it nicely separates the project into 3 layers: model, view, presenter. And each of these layers have single responsibility. The presenter takes care about the logic, and the view only about displaying something, which is really nice. It really makes the code readable. The presenters are also testable, because it's hard to test like Android stuff, Android activities. The presenters are decoupled from the activities, so you can easily test them. Yeah, as I said, it's really simple activities, no spaghetti code there, and it's maintainable for the future. For bigger apps, you definitely need architecture like that. So MVVM is also popular. We are using MVP. So now let's see our presenter for this screen. So this is how easy it is in the presenter. We just use this load function. I will show you how the load function looks in the next slide. So we use this load function. We call various paths in the Firebase, and if it's database combine, that's the function I showed you before. That's combining multiple paths in the Firebase into single observable. And when it changes, or when you get the data, I call methods on the view. So view is the activity, but here it's nicely abstracted in an interface. So when I get the data, I call the group owner, the edit permissions, the read-only permissions. This is the interface. So let's see the load function. I have the load function in the base presenter, so I implemented this only once, and all the presenters can call it. So the load function actually subscribes the observable. I subscribe it in the main thread. So everything is done on the background, and then it goes on Android main thread. I actually cache the value, which is returned. That's good for rotation, because after rotation I don't have to load it again. I just use this cache value. And if the view is attached, I call this function display to view. That's here. In Kotlin you can pass functions as parameters, which is really nice. So this load function takes a lambda here, and the lambda is called here with the data. And this method on view attached is called after the orientation change. So I will just go through the cache, and I will directly display the data. I will not load it again. That's quite nice. And also this method is called when the activity goes away and presenter read it. So automatically it unsubscribes from all the observables there. So I don't have to do it manually. And finally, this is the activity. So as you can see, the activity only cares about how to display something. It doesn't do any logic. It just gets the command from the presenter, like set the edit permissions. It will just set the data to adapter. Standard Android stuff, or it loads image here. Nothing special, and it's really easy. So one nice thing about Kotlin is that you don't need to call find view by ID. It automatically gets the views into your Kotlin code, and we use this naming convention that the IDs always starts with V, like a view. So, but it's just our naming convention. It's not Kotlin. So this is the name of the ID in the layout, which is then converted automatically to a variable here. Okay, so that's it. This is how it looks like. And before we go to questions, yeah, by the way, here is I think you noticed, but here is a link to questions. You can open it on your phone. You can type question, or you can also later ask on the mic. So let me repeat most important points. So Firebase is not just a database anymore. You don't really need to use the database. You can just use some other services, but it's really great. It helped us reduce a lot of code, mostly about synchronization and offline. But when we are using Firebase, you should really think about using RxJava and like learn it fully. It's great for combining multiple asynchronous calls together to display something on the UI. When you're doing this, really study these three operators. They are most important: map, flat map, and combined latest. All the others are quite easy to use, and you can use them just like one time, but these three I'm using all the time. Kotlin is great. If you are building new app, it's a no-brainer. Definitely use Kotlin. If you have existing app, you could do like one activity in Kotlin and rest of them, but stay in Java. But I think to get full advantage, then it's great that if everything is in Kotlin. You should definitely use some architecture. We use MVP. MVVM is also great. One thing I didn't tell is that our presenters survive the orientation change. So when you rotate the device, the activity is destroyed, but the presenter survives. That's why we can keep the cache data there, and also the observables we don't unsubscribe. And we use for this we use loaders actually to preserve the presenter. All code which I showed today is on my GitHub, so you can study it. And I have two bonuses. First is our app is also for Windows, and you know, Google is always saying we support all platforms: Android, iOS, and web. Nothing about Windows. So we solved it. That we wrote our own like .NET wrappers on top of Firebase APIs. So if you are a .NET developer and you want to use Firebase, check this out. We made libraries for the database, for authentication, and for storage. And second bonus is that we really need feedback for our new app based on Firebase. So if you are interested in our new app, here is a URL for the alpha version. Send me feedback here. And that's it. So thank you, and then we can go to questions.
Thank you. That was really interesting and cool.
Yeah. So, sorry, we will first do questions from here, and
Sorry?
then I will get back to you. Yeah. Okay. So. So Sergey asks, why return null and not empty observable as is intended in RxJava 2? Yes, if we migrate to RxJava 2, we would do this. But what I like about null is that you have these nullable types, so it forces you to think about nullability. So that's why we chose to really return null, because then it really forces us, okay, this could be null, so we need to handle this. And another question, but how do I fix RDD app? Okay, so in the RDD app, I think it's not really nice that you listen to the root of the database, and when anything changes, you change the current screen, and you should really listen just for the data you need for that exact screen. So for the example I showed, you should not listen to Firebase at all, because there is no data from Firebase shown there. It's just what user is typing. So you should only call Firebase when the user fills the form and sends it. I don't think so. Like it's pretty fast, and but definitely you don't need all the data. Like you don't need the feedback on the speakers, for example. If you are showing just the titles, yeah. Like we did some tests that in our app we have maybe like 10,000 payments into one group, and we load it with RxJava like this, and it's really fast, like, no problems. Okay. So.
Hello. So one question. The thing is that about using Firebase, it looks like that is really handy if you are like doing a startup or an app that you are just starting to develop. But what about those apps that have been in production for a while and that are using that already have some server information like in like internal server, and then suddenly wants to migrate? It will be like a huge thing to migrate all of the data to Firebase in order to
Yeah, sure.
to take advantage of
So
those things.
if you are using Firebase in an app, you can combine it with other data sources. Yeah, you can have your normal REST API, what you have, and maybe just the new feature will be in Firebase. Like you can get usually when you have some real-time functionality in the app, maybe some chat or some maybe dashboard which should be really real-time, then it's great to use Firebase. But for like your static data, maybe some really long data, historical data, it's still best to use like normal REST API. So yeah, so like you could do synchronization between Firebase and your server. So whenever something changes on one place, you will change it also on the other. Or if you really wanted that real time, or you could just call REST API and combine it using RxJava with Firebase data. You can do both. It's up to the use case. Okay.
Okay, so I have actually two questions. I don't know. Probably I'll ask one, then pass it over, and then take it back. So the first one is you showed Android only. So what about iOS?
Yeah, so it's quite similar on iOS. Like I'm not iOS developer, so that's why I don't show iOS
Okay,
code.
so
But the concepts are the same. There is also like reactive libraries on iOS, like RxSwift. We are using RxSwift on our iOS, but the concepts are the same. I just don't understand the code that much.
Right, thank you. Okay, that was a short answer. Maybe I'll ask the second one as well. So the second one is regarding kind of local development and testing. So how does that work? Is there some kind of a local proxy for Firebase, or do you have to be online to actually, test everything? Or
So what we do unit test with like mock data. So we don't work with Firebase directly.
right.
We are just passing like mock objects.
Yeah, I understand. But sort of when I am developing the application and I'm offline, I'm on a plane, then I don't have a data source. Or do you have a mock data source for Firebase? And if you do, then
yeah, we just call functions with mock data.
right,
It's
right,
no
okay.
big deal. Yeah. And we also have some unit like UI tests, which are, you know, like end-to-end tests, like clicking on the buttons. But that's another set of tests. Yeah.
So how did you solve the cloud code thing? Because Firebase doesn't support any code.
It
I mean,
supports now.
any logic.
So like 2 months ago, they introduced a new Firebase feature, which is called Firebase Cloud Functions.
So you're
And this is
already
exactly
using it.
Yes. We have used it even before we were in some early access program, but now it's finally public. I can talk about it. So you can add like little pieces of JavaScript code, which are triggered by some changes in Firebase and do some custom logic on the server.
So are you happy with it?
Yeah.
Is it good?
Finally, like I think it was the biggest missing thing in Firebase.
I think so. I think also.
Yeah, I was wondering about that question mark you put. Yeah, this one. In the code you showed that from the Firebase you kind of get null objects. In which scenarios it could happen, and so why that you still pass that question mark to other code places? Like, can it be skipped, like ignored?
Maybe in some apps, but in our use case, it could happen that somebody removes you permission to the data. Yeah, like somebody removes you from the group, and in that case, you get like uncancelled callback, which is like an error, permission denied, and we use null in that case for propagating this information to other parts of the code.
Okay, thanks.
So I believe that you could just don't pass null as on next from the observable, but just let's say raise an exception. But then you would have to catch exceptions in your streams and make sure that then you just return something else, like on error return next. So and basically the null value is also a reason why you cannot easily convert that to RxJava 2, because with RxJava 2 you are not allowed to emit null value.
Yes.
So, yeah. So that's
you are right. I think if we convert to RxJava 2, we
then
would
you
have to do this.
Yeah, exactly.